Alright, so in this lesson, we're going to be going over a new type of equation called exponential functions. So an exponential function has two parts. The first part is going to be called the growth factor. You can think of that as the multiplying pattern. So for example, from 15 to 45, notice that it's times 3. So times 3 to get to 45, times 3 to get to 135. Going backwards, our initial value, which is at 0, that's going to be 5, because 5 times 3 fits the pattern. And the way we write the equation is the initial value is going to be replaced with a. That's the number that's by itself. And the starting point, the growth factor, 3, that's going to be next to the exponent. Notice how it's times 3 times 3 times 3. Notice how 3 is being repeatedly multiplying. That's another way of saying exponents. We're just multiplying 3 over and over again. We can find the same information from a graph. So here we see that our 0 point, our initial value, is at 12. So I'm going to replace a with 12. And notice that from height 12 to height 48, we're multiplying it by times 4. 12 times 4 gets us to 48. So our multiplying pattern is 48. It's times 4. Okay. So today we'll be connecting different representations. So if I see an exponential pattern in the table, a graph, an equation, how are those all related? So here we're starting at 0, 5. So my starting point's at 5. And notice that I'm going from height 5 to height 7. So the way I can find the ratio, this multiplying is not going to be a whole number, it's going to be a decimal. So one way of figuring that out is I can take the next height, which is 7, and divide it by what it was before. Again, takes the next number, divided by what is before. Again, we're at height 7, before we're at height 5. So that ratio is going to be 1.4. So 5 times 1.4 is 7. Let's try the next one. So here, my initial value at 0, so I'm starting at 40. So I'm going to replace a with 40. And I'm going from height 120 to height 40. Just like before, I can take the next number, divided by what it was before, and see that my ratio is 0.333, or 1/3. So this is going to be 1 divided by 3. So starting at 40, and each time I jump down, I'm losing 1/3 of my height. Okay. Here, for this next one, we're starting at 18, so our initial value is 18. And the way I keep a straight line is that I can keep multiplying by times 1. So if I keep multiplying by times 1, times 1, times 1, it's going to make a straight line. All right, for A4, here we're starting at 7. And now I'm asking, how many jumps does it take to get up to 56? So notice that after one jump, if my pattern is times 2, right? Notice that after one jump, I'm at 14. So at one jump, I'm at a height of 14. At the second jump, I'm at 28. So at height 2, I'm at 28. So that's another times 2. And the final times 2, at the third stop, I'm at 56. Okay? So it's times 2, times 2, times 2, and that's how I get to 56. You might notice that this last question is a little bit more difficult than the other ones. So for section B, we're going to explore this question a little bit further. So here we're trying to write an equation for this one. Notice that Errol is saying that he thinks A must be 10 because that's the y-intercept, and we agree. All right. His teammate Sandy says this must be the equation. 320 equals 10 times b to the 5th power. This matches because here's our A, right? We said that A is 10. At the 5th jump, so at the 5th spot, we're at a height of 320. So here we're at 320. So here, this equation has all the information that we need. So is this equation valid? Yes, it's valid. So let's solve this equation. How do I solve for b? First, we need to divide both sides by 10. So 32 equals b to the 5th. Remember that exponents means repeatedly multiplying. So this means that I have 5 b's all being multiplied together. Oops. 2, 3, 4, 5. So now I need to think about what number, if I keep multiplying, will be 32. Right? I know that 2 times 2 for a total of 5 times. 1, 2, 3, 4, 5. 2 times 2 times 2 times 2 times 2. That's going to be 32. So b has to be 2. So for this equation, no. All right, so here our starting point is going to be at 10, and we're multiplying times 2. Okay. So for this third one, Here we need to figure out what our y intercept is. Notice that 0, 5, our starting point's at 5. And then from here, we need to write an equation. Again, a is 5 from before. At the fourth jump, the fourth spot, x is 4. Oops, make that 4. We know that our height is going to be at 1,280. 1,280. So now we need to solve this equation. We can divide both sides by 5. So we get 1,280 divided by 5, which is 256, equals b to the fourth power. B to the fourth power means I have 4 of these b's. So what number times itself 4 times is going to be 256? And that turns out to be 4. Notice that 4 times 4 times 4 times 4 is 256. So my b is 4. So here I'm going to plug in b equals 4, and we're starting at 5. All right, for part C, we're going to go backwards. Here we're starting with the equation, and from the equation can we make a graph? So I know that my starting point, the number that's by itself, is 5. So I'm starting at 5. And I know that the height is being multiplied times 3. So the next jump, 5 times 3, the next stop will be at 15. So a sketch, it doesn't have to be perfect. As long as I know that it curves, we go through 5, and we go through this height. Okay. Now for C2, this time we're starting at 10. So I'll put my green starting point at 10. And I know that the next jump is going to be half of what it was before. So the next jump will be half of this, would be 5. So my sketch, this one's going to be going down because I have a fraction. All right, we're cutting this in half, and it curves. All right, for this one, we're starting at a height of 1/10, which is 0.1. Whoops, 0.1. And then my next jump, 0.1. And my next jump is going to be times 5. So 0.1 times 5 will be at a height of 5. So when I sketch this curve, it's going to bend. It's going to cross this line, and then it's going to hit this line, and then curve back up. Okay? So that's what that graph's going to look like. Section D, we have this word problem. And based on the word problem, can we write the equation and make a sketch? So here we have 1,800 trout at the start. So 1,800 is going to be our initial value. And here we know that the rate of fish is decreasing by 1/3. So that's going to be my growth factor. B is going to be 1, highlight, divided by 3, 1/3. So for my sketch, I'm starting with 1,800 fish. And after the first week, I have 1/3 of that left. So 1,800 divided by 3 is 600. So when I sketch my graph, it's going to go through these points, and it's going to start to bend and curve like this. Okay. Second situation, here we have it cost $7,000 in 2010. So that's at the start, 2010. And then after the first year, it increases to 7,700. Again, the way that I find my ratio is I take the next number, the height of 7,700, divided by what it was before, 7,000. So see that my multiplier is 1.1. So my multiplier is 1.1, height of 7,000. Okay. How much would it cost in 16 years or in 2026? So I'm going to copy and paste my equation. All right, instead of x, 16 years later, which would be in 2026, because again, this is starting at 2010. So 16 years later from that, college is going to cost around $32,000. Okay. So what are some strategies for connecting graphs, tables, and equations? So in all these representations, an exponential function has a growth factor, which is the multiplying pattern, and an initial value. So the secret to connecting all these representations is finding these two things. You need to be able to find the growth factor, whatever it's multiplying by, and you need to find the initial value, the starting point. So finding these review and preview problems, let's see again. Our starting point's at 4, so I'm going to replace A with 4. And here, my next point, I'm jumping from height 4 to height 7. So my ratio will be 7/4. Again, next divided by previous. I'm starting at 4. Next jump would be at 7. So my ratio is 1.75. All right. Preview number 2. Here we have 2 tables. The trick for this first table is that this is not a multiplying pattern. You might think it's times 4, but if I tried times 4 again, it would not be 3,500. This is actually an adding pattern. So this is in the form of mx plus b. I'm adding 1500 each time, and I'm starting at 500. Over here, this is the one that we've been looking at, the multiplying pattern. Right here, I'm starting at 30. At 0, we're at 30, so that's my starting point. And then it's times 5, times 5, times 5. 30 times 5 is 150. So my multiplying pattern is 5. All right, for the last two, here we're solving for x. So I want to get x by itself. So to get x by itself, I'm going to get rid of the y, minus 5y, 5y, minus 5y on the other side. So these cancel out, because again, I want to get x by itself. I want to solve for x. So I'm left with negative 3x equals negative 5y minus 10. And then finally, to solve for x, I need to cancel out this 3 by dividing by negative 3. But whatever I do to one side, I need to divide this on the other side. So notice that times negative 3 divided by negative 3, multiplication and division cancels out. So I'm left with x equals, I have this part, I'm going to copy and paste, and I need to divide this part by negative 3. Okay, so that's solving for x. For the next one, here we're going to also solve for x, so we're going to get x by itself. Right now we're going to get rid of this plus b by subtracting b on both sides. So we have y minus b equals mx. And then to get x by itself, I need to get rid of this multiplication. I need to divide both sides by m. Divide this side by m. So after dividing both sides by m, notice that times m and divide by m, these m's cancel out, so I got x by itself. And on the left side, let's put this on the other side, I have y minus b. And I'm going to divide this by m. So I solved for x, I got x by itself. For this last one, here we have a word problem, and we're going to write the equation. And it's going to be the form of a times our growth factor with an exponent. If we read the word problem, notice that our initial population is 300. So we're starting off with 300 snakes. And now it's asking what our rate is going to be. So when you think about, if we're losing 12%, so we can think of that as, actually let's move this to the other side. All right, we can think of this as we have 100% of the snakes, and we're subtracting 12% of them, right? We're decreasing by 12%. So 100% minus 12%, we're left with 88% of snakes. But again, we can't use a percent in our equation. So 88% is going to be 0.88 as a decimal. All right, you still have questions after watching this video, just send me another email, and we can go over that. All right. Sure.